Problem 6-2. Describe what moves you could use to create the transformation of the original image shown below. Okay, so here's our original image right here. And here is the image that we would like to transform it to. Okay, so I'm going to describe those moves. We do have a tool here that you might want to use, but I'm going to use paper just because it's a little easier to show you what I'm doing. Okay, so here's our original. I've redrawn this, and it looks like we're going to have to take this original and flip it because here it sort of looks like this base ends up over here, and this little part that goes up like a tent ends up over here. And so probably the best way would be to flip it over the x-axis right here. So let me label that so it's easier to see. All right, so let me show you what I'm talking about. So I'm going to take a piece of patty paper and I'm lining it up with the x-axis there. Or I could just do this. So I could draw the x-axis there so I can see where, this line of reflection is. And then I'm going to draw the original shape, just sketch it over. So if I flip it, so I would be taking this and flipping it over, and then I line it back up with the axis, and we can see that now it looks like it's the same shape. So it looks like flipping it over the x-axis is going to be a good first move. And so remember, we've got 3 different types of moves. We've got translations, which that means sliding. We have rotation, which means it's going to turn. And then we also have this reflection, which means that we're essentially flipping. Okay, so that's our first move, is going to be, we are going to reflect. And when we do a reflection, we need to specify what the line of reflection is. And in this case, the line of reflection is going to be the x-axis, which we specify that by saying y is equal to 0. Because we know that anywhere along the x-axis, y is equal to 0. So that's a good way of defining this line. Okay, so now if we've reflected it and we've gotten it up here, we still need to move it over here. So that looks like a good candidate for what we call translation or sliding, because we can just slide it over right on top there. Okay, but we need to figure out how far we need to slide it. So we know the direction is going to be in the x, along the x-axis, and we need to count. So it's a good idea just to pick one of these corners here, one of the vertices, and count how far it takes to get it over to its new location. So 1, 2, 3, 4, 5, 6, 7. Okay, so it looks like we're going to have to move the whole thing 7 spaces to the right to get it there. Okay, and you can take any one of these corners and count. So if we pick this corner, we could count again. 1, 2, 3, 4, 5, 6, 7. It's always 7. And this point, 1, 2, 3, 4, 5, 6, 7. So any one of these corners will do for counting how far we're going to move. Okay, so we're going to say that the second move we'll make is a translation. Translate. And we need to specify, first of all, the direction. So we're doing it along the horizontal, or the x. And it's going to be x plus 7. And we know it's a positive 7 because we're moving in the direction of positive numbers. So the numbers get bigger and bigger as we go this way. So that would be x plus 7. Another way of specifying it would be 7 units to the right. Okay, so we've finished our transformation.